So what we're going to do this morning is talk about another example, more interesting example, more complex example of applying completable futures. And this will be a revision of the ImageStreamGang example we've looked at several times before, except this time we're going to show how to implement the functionality using the completable futures version as opposed to, say, parallel streams that we had talked about earlier. So as we'll see here, there's a bunch of interesting completable future features we're going to talk about. The way that this is going to work will be that we'll ignore the cached images, which we've done before. We'll download the non-cached images, of course, using asynchronous processing in completable futures. We'll apply a list of filters to transform each image, again, asynchronously using completable futures. We'll store the filtered images in the file system asynchronously using completable futures, and then ultimately the images will be displayed to the user. That processing is done using an activity and does not involve completable futures, but all the information that's created would have used them in order to get the images downloaded, filtered, and stored. The behaviors that we have in this particular pipeline differ from the parallel streams variant we had talked about before. In particular, you'll see as we look through this, each of the steps in the pipeline uses asynchronous processing as opposed to synchronous processing. So we'll ignore the cached images asynchronously by using a method called check URL cached async, which, as the name suggests, will asynchronously check if images are cached. We'll download the non-cached images asynchronously, again using behavior, a method reference called download image async. As the downloads complete asynchronously, and of course they could complete at different times because naturally they're all downloaded in parallel, and that's, a longer image will take longer to download, a shorter image will take shorter time to download, but whenever they complete, they will be filtered and stored in the file system, and that will of course all be done asynchronously. And then all the streams processing will start up, and that will actually kick everything off. So interestingly enough, none of the operations here actually start running until collect is hit. And it's going to use a similar technique that we had talked about in the last class when we discussed the futures collector, which takes a stream of completable futures and then returns a single completable future where all those completable futures will be connected to notify that through that single completable future when all the other ones finish running asynchronously. And we'll look at that in more detail. After everything is finally stopped running, then we'll get all the results and we'll log it. And at that point, you could display them. OK, so that's kind of the big picture view. What we'll do here is kind of talk about how combining completable futures with streams does a really interesting job of closing the gap between the design intent, which is the requirements to download and filter and store and so on, and the actual implementation details. This example is really quite fascinating, but it's a little complicated and tricky to understand. So as always, we'll look at it from multiple different perspectives in order to be able to give you a sense of how it all works.